Welcome to another Teacher Tobin tutorial. We're going to be exploring topic 1, bubble sorts, from the Edexcel GCSE Computer Science course, which with the specification here be 1.2.6, and we'll do an exam style question after going through what bubble sort is. Now, it should be noted that bubble sort for large data sets is not very efficient. It's not part of the Edexcel specification, but we would, in terms of big O notation, we would call this a quadratic O to the n to the power of 2, right? So big O is just a way for mathematicians to describe how efficient particular algorithms are. In comparison, the other sorting algorithm that's mentioned in Edexcel is merge sort, which is far more efficient n log n. But for small data sets, actually, it doesn't make a lot of difference, and there's quite a lot of setup involved for a merge sort, and it uses recursive algorithm. So it potentially might even be faster to have bubble sort. So let's just go through what bubble sort is. We have what we call passes, and in each pass we're going to be comparing all the numbers side by side, all the pairs of numbers, and deciding which one, left or right, is bigger than the other. So in our first pass here, 41 is certainly bigger than our 15. So therefore, I'll just say first pass. If we've got a bubble sort algorithm and we're running it on this, it would be an array of integers. In this case, an array is when they're all the data type, the data types are all the same inside. So we would say, okay, the first two numbers are compared, and we would be swapping those. So let's just do that. 17, 32, 18, 28, 77, 54. So none of the other ones have been touched yet. And then the next time around, it's going to look at these two and decide that those two need to be swapped around. So it would be 15, 17, 41, and all of the others would stay the same. Or let's just write 32 in there. Let's make sure we've got 32 in there. All the others are the same. And then the next time around, it's going to look at 41 and 32 and decide, okay, so we've got 15, 17, 41 and 32, they need to be swapped around. So we're going to swap those two round. 18, 28, 77, 54. And then we're going to be looking at 41 and 28. So all of those are going to be the same, but 18 and 41 are going to get swapped around. 28 will stay the same because we haven't got to those yet. 32, 17, 15. And of course, you can probably guess what the next one is. So we're you can see here, we're going across and looking at each adjacent pair and seeing which one's smaller than the other. So here, 28 will get swapped to 41, 27, 54, 18, 32, 17, 15. We're still on the first pass. This is still the first time our algorithm's going through everything. 41 and 77. Okay, well, those are already in the right position, so we don't need to change them. So I'm just going to write them all out again, just so it's easier to see. 41, 77, 54. And then finally we were looking at these two. So of course 41, 54, 54 and 77. So what we have here is after the first pass that. Now, is it sorted? Well, 17 is bigger than 15, 32, but we've got an 18 here, so we still haven't sorted it completely, have we? And that 28 needs to be up there. So we'll need to do another pass to sort this. It's not going to be completed on the first pass. So let's do a second pass on this array. So I'll put the numbers in. And you can probably start to see that for large data sets, this would be highly inefficient, because the amount of swaps we're making for n amount of items, 1, 2, 3, 4, 5, 6, 7, 8, 8 to the power of 2. So 15, it's going to look at those two first and decide that they're the same. No problem. So a lot of typing out here. I'm going to look at these two, decide that they are actually the same, so that's fine. When I say the same, I mean the 17 is smaller already than 32. Here we need a swap because 18 is smaller than 32, but it's on the wrong side. (28), 41, 54, 77, and then we're going to look at these two. 28 needs to be swapped with 32. 41, 54, 77. And then we're going to be looking at these two, and they're already fine as they are. 32 is smaller than 41. And then we're going to be looking at these two, and they're already in the right place. Most of these numbers actually seem okay. And we're going to be looking at these two, and they also are in essentially the right place. So we didn't need to do any swaps there. However, this is, why am I putting 4 in there? That should be 7, 7, 7. Sorry about that. Here's the issue though. Our computer algorithms done its second pass, but it doesn't actually know, it doesn't realize that this is sorted yet. So even though we know it's sorted because all the numbers are in ascending order, the computer needs to do a third pass. It needs to do a third pass in order to actually understand that it's sorted. And if no swaps are made in the third pass, then we know we've got a sorted array. So yes, it will go through all of these and check, and it will realize, I didn't need to do anything to that one. Nothing was swapped around. So in that case, it is sorted. It is a sorted array now, but it took a third pass for that to go through. So let's have a look at an exam style question. Here we go. A bubble sort is carried out on this list to put it in ascending order. Now they usually use words like array, but it's fine. The closest we have in Python to an array is a list, which technically can have different data types in them. But anyway, these are all integers, so let's just work with it. The value 8 starts in position 0. Okay, good. So 0, 1, 2, 3, 4, 5, 6. In Python, we start from position 0, especially in a list. Now, confusingly, sometimes in pseudocode, we start from counting from 1, but in paper 1, you're not going to see that. You're just going to see Python style code, which is quite nice. You'll only see pseudocode in paper 2. So, state the number of passes required to complete the sort. So let's have a look at it, shall we? So 8 and 3 are going to be compared and swapped. Then we're going to look at 2 and 8. So 3, 2, 8. Oops. Give me a second. 8 and 4 are going to be looked at. 3, 2, and they do get swapped around. And 8 and 0 are going to get looked at. 3, 2, 4, 0, 8, 3, 9. 8 and 3 are going to get looked at. 8, 2, 4, 0, 3, 8, 9. And then 8 and 9 are going to get looked at. It's going to stay the same. So that's definitely our first pass. So we've got one pass already. Now let's just have them listed out again over here. 3, 2, 4, 0, 3, 8, 9. So here, 3 and 2 are going to get looked at. They're going to get swapped around. 3 and 4 are going to get looked at. They're going to stay the same as they are because they're already in position. 4 and 0 need to get swapped. Um, 4 and 3 need to be looked at. 0, 4. So I'm going to try and get these ordered nicer here. 8, 9. 4 and 8 need to be looked at. They're going to stay the same. And then 8 and 9 are going to stay. That's going to stay the same. So that is our second pass. Yeah, first pass, second pass. Let's do another one because they're definitely not sorted yet. So 2 and 3 are going to get looked at and they're going to stay the same in position they are in because they're already in the right position. Then 3 and 0 are going to get looked at and they're going to get swapped around. 8 and 9. Yeah, I should have written that slightly better. Anyway, 3 and 3, they're going to stay the same. Here we go. 3 and 4 are going to look at. That's going to end up being essentially the same position. 4 and 8 are also going to be in the same position, and 8 and 9 are also going to be in the same position. So we had a third pass there. And then let's keep going. And this is pretty tedious for a one mark question, but if you can get through this, I think it's worth it. So let's do 2 and 0 are going to get looked at, so it's going to swap around. 4, 8, 9. Then 2 and 3 are going to get looked at, they're going to stay the same. Those are going to stay the same, those are going to stay the same, those are going to stay the same, those are going to stay the same. So that's our fourth pass. But the thing is, the fourth pass, the algorithm still doesn't know that this array sorted. It requires now a fifth pass to actually realize that all our numbers were in order at the end of the fourth pass. So that's pretty tricky for a one marker. It's not very generous, is it? But the bubble sort algorithm isn't too difficult. It's one of those simpler algorithms to understand how it's working. But this idea of passes and checking for the sorted array, sometimes requiring another pass, that's a bit tricky. So even though no swaps were made here, we have to have that full round of going through all the numbers again just to check if no swaps were made. That's the key thing to remember. So I would put in the answer finally for a 1 mark question, which has taken way too long in the exam, because usually it's about a minute per mark. 5. Okay, so you didn't have to necessarily write it out all like I did, but doing that helps me make sure I've got the right answer. Okay, state the number of swaps made on the final pass. Well, this is why it's been beneficial to do it the way I did, because we realised that there were no swaps made on the final pass at all, because the list was already sorted at the end of the fourth pass, but it required the fifth one to vote. It will probably be called swapped, and then you may have a true or a false Boolean value attached to it, and we may have some sort of condition controlled loop, a while loop, which keeps on running until we get, say, swapped equals false, and maybe that stops the loop from running. So it might be something like while swapped. I'll show you in another video what, in fact, with the power of editing, I might be able to show you here. Once we've done this question, I'll show you an equivalent Python file for a bubble sort. Let's just go through these questions first. State the position of the item that will be compared with the value in position 0. Well, position 0 is the very first number, and of course the next number is at position 1. So the very first time we ran this, at position 0 was 8. It tells you that, and that will be compared with position 1, which was the 3, and it gets swapped around. So define the term iteration. Now this is where I've got a little sort of bugbear with Edexcel, because they use two terms, condition controlled loop, and what they're referring to there is a while loop. So while might be keep on going as long as swapped equals true, just as an example. While true, I mean, it's the same as saying while true here, if you just put while swapped. Condition control loop, but the term iteration could also apply to while loops, so it's a little bit misleading, I think, in terms of how they've decided to define that. But what you need to know is a for loop will iterate over each item. So you could say looping over every item in a data structure, because we don't know what data structure that is. It could be a list, it could be a string even. To be safe, just put data structure. So essentially you need to have in your mind that iteration means for, or count controlled. Sometimes they'll call it count controlled, especially if you've got a for I in range loop, for I in range of a certain value of numbers. Look at each thing. For loops always stop. While loops potentially can go on forever, which can cause obviously infinite loops and things like that. So there's quite a lot to unpick there in that question, lots of terms and ideas, and it's a little bit long-winded, but bubble sort is worth persevering with and understanding. So let's just have a look at some a Python script for bubble sort. We return a value, so we know this is a function. We define our function with def. We've got a parameter called array, and we pass through this argument here, which is a, which we know is an array. Gets passed through this parameter. And then we've got a nested for loop, which is usually in programming where you get quadratic terms and squared, especially when you have nested for loops. Not always, but most of the time if you've got a nested for loop, you're going over the items in quadratic time. So for I in range of length of array, so the length of the array 1, 2, 3, 4, 5, 6, 7 is 7. And then here we go, so we've got swapped equals false, a bit like that question that we just went through. State the component of our algorithm to store whether a swap has been made. So in this case, they're not using a while loop there, they're using for loops, that's fine. But we do have a variable called swapped, and it's got a Boolean value in it. That's the main takeaway from that. So so I is going to take on the value 0 to begin with. And then while I is 0, j is going to go from 0 as well, all the way to the length of the array minus that particular I, which in this case is 0, and then minus 1. So one length is going to reduce that length of the array. So it'll be now 6, 0 to 6. And 1, 2, 3, 4, 5, 6, because 0 is at the end of the array. So that's where this 6 is going to get useful, because you might, if you don't have that, then it will say, oh, I'm trying to find something next to it, but I can't find it, and then you'll get you'll get logic issues there. So if array at position j, which we know is 0 at the moment, is greater than 0 plus 1, so that's 1, is 4 greater than 6 essentially, then swapped equals true. However, in this case, that's not going to be happening because 4 is not greater than 6. So if not, so we're not at this point yet anyway, sorry. If not swapped, break. So that's where I was saying to you, this could become true. So if not swapped, not would be the opposite of false, which is true. If that becomes true, then it stops the loop from running and we return our array. So this only gets into action if that condition is met. If it's not, it stays where it is. Okay, so these for loops keep on going round and round and round, and if the array at index j is greater than the one to the right, like in the next case. So if I change that, if I put the second time it goes around, if that's a 6 here, and is that j plus 1, which would be 2, if array is greater than 2, yes, if 6 is greater than 2, swapped equals true. So we've changed the value of that, and we know, because it's keeping track of whether it's swapped a number or not. And array at j, which would be in this case 1, and then j plus 1, 2, and then it's essentially these just swap around. This is just a way of swapping the variables around. So that's quite a lot to unpack in this one. Obviously the question didn't need you to do any of that Python work, but this was a typical exam style question to make sure you understood how bubble sort works. I hope it was useful for you, Again, don't worry about this. That's not in Edexcel. It'll probably be more A-level work, but it's useful to know. Now, we can talk about efficiencies of algorithms in another video, but generally speaking, for large data sets, you want to avoid bubble sort. It's not efficient. But for small data sets, it's actually fine. For a really small list of integers, it might even be slightly quicker than merge sort, because merge sort requires recursion, and also the list has to be copied many times, whereas the bubble sort's in place. So it gets a little bit murky with very small data sets. But for large data sets, definitely want to avoid this. Okay, see you in the next video.